Let's understand which is faster, Python lists or NumPy arrays, and why. NumPy arrays are faster for numerical tasks. That is, when working with numbers and calculations, NumPy is much quicker than Python lists, and NumPy arrays are built for efficient computations. That is, NumPy is designed specifically for array operations like addition, multiplication, and more, all optimized for speed. Also, NumPy is implemented in C under the hood. That is, NumPy operations run using compiled C code. That's why they are much faster than regular Python operations. Whereas Python lists are slower for math operations. That is, lists are more general purpose and they are processed using Python's interpreter, which adds overhead. And when it comes to vectorized operations, NumPy can perform operations on entire arrays at once, whereas Python lists loops through each element. So the takeaway is NumPy arrays are faster because they use optimized C code and perform operations on entire datasets at once, unlike Python lists. Okay, let's understand the difference between a Python list and a tuple. Both list and tuple store multiple items. That is, lists and tuples are used to store collections of data in an ordered way. And lists are mutable. That is, they can be changed after they are created. That is, you can add, remove, or modify elements. For example, you can update values anytime. And tuples are immutable. That is, they cannot be changed after they are created. So once created, you cannot modify, add, or delete elements. And they both have different syntax. That is, list uses square brackets, whereas tuple uses parentheses. And when it comes to built-in methods, lists have many methods. For example, append, remove, etc. And tuples have very limited methods. And if you compare performance difference, tuples are generally faster and use less memory, whereas lists are more flexible but slightly slower. So the takeaway is, use lists when you need flexibility and tuples when you want fixed, faster, and more memory efficient data storage. Okay? Let's understand what are Python sets. Sets are collection of unique items. So set stores only distinct, that is non-duplicate values, and set is unordered data structure. That is, elements in a set don't follow any fixed order, and set is defined using curly braces as shown here. And the key properties of sets are no duplicates allowed. That is, if you add the same value again, it will be ignored automatically. And set is unordered, that is no indexing. So you cannot access elements using index-like lists, and also you cannot do slicing. And set is mutable, that is you can change, so you can add or remove elements using methods like add, remove. And set is used for fast membership checking, that is very efficient for checking if an item exists in the set. And also set is not hashable, that is sets cannot be used as keys. Since sets are mutable, they cannot be used as dictionary keys. And you can use frozen set if you need an immutable version. So the takeaway is, sets are perfect for storing unique values and performing fast lookups, but they don't support order or indexing. Okay? Let's understand the difference between split and join in Python. So split function breaks a string into parts. That is, it splits a string into a list based on a delimiter like space, comma, etc. You can see the example here. This is our string. AI is transforming the world, and we are calling the split function based on the delimiter space. You can see the output. It splits the string by space, right? And join function combines a list into a string. It joins multiple strings into one using a delimiter. For example, we are trying to join all these words, and you can see the output here. And the key difference is split function breaks string into list, whereas the join function combines a list into string. So the takeaway is, split function separates a string into parts, while the join function brings those parts back together into a complete sentence. Okay? Let's understand what are logical operations in Python. So logical operators are used to work with true and false values. We have these different types of logical operators. First one is an operator. This returns true only if both conditions are true. For example, a true and true equals to true. That means when both the conditions are true, then the result will be true, and true and false equals false. And the next logical operator is OR, that is at least one true. So the OR operator returns true if any one condition is true. For example, a true or false equals true, and false or false equals false. And the other logical operator is not. It reverses the value, that is, it flips the Boolean value. For example, not true equals false. Similarly, not false equals true. Now let's see a simple real life example for the logical operator, and you need both conditions. For example, login plus password should be correct in order to log in. And for the OR operator, either condition works, that is either email or phone login, and not equals opposite of a condition. So the takeaway is logical operators help you combine and control conditions using true and false in Python programs. Okay. Let's understand top Python string functions you should know. The first one is len function. This is used to find string length and it returns the number of characters in a string. For example, len of data science equals 12. Okay. The next one is strip function. It removes the extra spaces and it removes spaces from the beginning and end. For example, Python rocks.strip, you can see it removes spaces, right? And the next one is split function. It breaks string into a list. That is, it splits a string based on a delimiter. For example, we are trying to split the string apple, banana, cherry by this delimiter. And you can see it return the list. The next important function is replace. It replaces text. That is, it replaces part of a string with something else. For example, string I love Java dot replace Java with Python. So you can see it replaces Java with Python and it becomes I love Python. And the next functions are upper and lower. Upper function converts the string to uppercase and the lower function converts the string to lowercase. For example, here by using upper function, we are converting the string machine learning to uppercase, and here AI model has been converted to lowercase. So the takeaway is these basic string functions that can help you clean, modify and analyze text easily in Python. Okay. Now let's understand what is the pass keyword in Python. Pass keyword means do nothing. That is, it's a placeholder statement that doesn't perform any action. So it's used when code is required but logic isn't ready. And Python expects some code inside functions, loops or classes. In that case, using a pass keyword helps avoid errors. And these are some of the cases where the pass keyword is useful inside an empty function or inside an empty class or inside loops or conditions. And why can't we leave it empty? Because Python will throw an indentation error if nothing is written, right? And pass keeps the code syntactically correct. So the takeaway is pass is a placeholder that lets your code run even when you haven't added logic yet. Now let's understand what is the continue keyword in Python. Continue skips the current iteration. That is, when continue is used inside a loop, it skips the rest of the current iteration and moves to the next loop cycle. That is, instead of finishing the current loop step, it jumps directly to the next iteration. You can see in this example, here we are trying to loop through 0 to 4 and want to skip when the I value is 2. So you can see the output as 0, 1, 3, 4. So when I equals 2, the loop skips printing, then continue with the next value. So when to use the continue keyword? When you want to skip unwanted values. Also useful when you want to ignore certain conditions and to keep loops clean. That is, it avoids deeply nested if statements. So the takeaway is continue keyword is used to skip the current loop step and moves directly to the next iteration.